This video addresses section 3.5 of Math 95. We're going to be talking about many different types of equations of lines, many different forms. We have many objectives, so this will probably be at least 2 videos long, perhaps 3. We would like to use slope-intercept form to write the equation of a line, to graph those lines with their slopes and their intercepts. We're going to learn about a new form of the equation of a line called point-slope form. We want to write equations of vertical and horizontal lines, and then find equations of lines parallel and perpendicular to lines we already have. So let's start working with slope-intercept form. I'd like us to write the equations of lines with our given slopes and vertical intercepts, and we want to put them into slope-intercept form. As you may recall, slope-intercept form is y equals mx plus b. M is the slope, b is the y component of the vertical intercept. So, looking at this first line, we have a vertical intercept of 0, negative 1/2, so b equals negative 1/2. And we have a slope of 5, so our m equals 5. If I'm going to write the equation of this line in slope-intercept form, it's really just plugging pieces into the equation. We're going to keep our y equals, we're going to have our 5x plus our negative 1/2. Now, this doesn't look very simplified. If I were to write this equation as a final answer, I would not have a plus and negative. I would really write this as y equals 5x minus 1/2. And that's our slope-intercept form of this line. So let's try it with the other line. We have our slope and our vertical intercept. So it's not necessary to identify b equals negative 1/2 and m equals 5, or m equals negative 1/2 and b equals 6 for this next case. We can really look at the vertical intercept and the slope and compose our equation just from looking at this. So when I see these two pieces, I know immediately my equation is going to look like y equals negative 1/2 x plus 6, just from taking these two pieces. On a test, if you were supplied with this information, this is all of the work that you would need to show. I don't need to see all of these other little bits. So now I would like to graph lines given a vertical intercept and a slope. So remember that when I'm given a blank grid like this one, before I can do anything else, I'm going to need to scale it and label my axes. So I like to use y and x when I'm dealing with graphs. So I will put a y up on this axis and an x over here. I'm looking and I'm seeing a vertical intercept of 6 and a vertical intercept of negative 1/2. So if I count my grids out, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, if I would like to fit my 6 on there, I should probably let these go by 1s. So I will do that. I'm going to label my axes with a scale. So, as I look at this first line, I have a vertical intercept of negative 1/2. So I'm going to grab a color. I like green. This one will be my green line. And I'm going to put my vertical intercept at negative 1/2. Now, I'm clearly not at exactly negative 1/2. I am guessing a little bit as to where this location is. From here, I want to incorporate my slope. And I want to think about slope as rise overrun. So for us, that would be 5/1. What this is telling me is to go up 5 units, 1, 2, 3, 4, 5, and over to the right 1 unit. And I could also go down 1, 2, 3, 4, 5, and to the left 1 unit. And it's always rise over run from the vertical intercept. And it's a good idea to go both to the left and to the right of the vertical intercept. So at this point, I'm ready to graph my line. Grab all of my graph pieces. Let's see, I want the arrows, and I'd like it to be in green. And so at this point, I am going to just connect my dots. So, too far, so we'll go about here, through all of my points, and just continue it on up the graph. For my next line, let's do it in, let's do red. Let's do Christmas colors. So this will be my red line. I'm going to start this at the vertical intercept of 0, 6, 1, 2, 3, 4, 5, 6. That's not very precise at all. Try that again. That's a little bit better. From here, I'm going to find the slope of -1/2. This means I'm going to go down 1 and to the right 2. So from this point, I'm going to go down 1 unit and to the right 2 units. Down 1 unit to the right 2 units. Alternatively, I could go up 1 and to the left 2 units, because that would be negative in the x direction. Up 1 to the left 2 units. Up 1 to the left 2 units. So if I connect these red dots in a line and choose the red, I will have the equation or the graph of that other set of information. I forgot to answer one of the questions on that slide. The other thing I'd like to know is, what are the equations of the line? So I almost missed this. Let's come back in here. This is what we were doing on the previous slide. My green line is going to have the equation y equals, plug in my slope, 5x, and my vertical intercept, -1/2. My red graph is going to have the equation y equals -1/2x plus 6. If these equations feel familiar, they should. They were the equations we dealt with on the previous slide. So, those were the two that we were dealing with. Okay. Now, I would like to graph the equation 3x plus 2y equals -2. And I want to graph this line using its slope and vertical intercept. This equation is not in slope-intercept form, so I can't actually tell what either of those pieces are yet. So my first step should be to get this into slope-intercept form. So let's just write that note down right now. Get this equation from, do you guys remember what equation it's in right now? It is in standard form. So I would like to get the equation from standard form into slope-intercept form. That's our y equals mx plus b. So I need to isolate y. Okay, so if I have the equation 3x plus 2y equals -2, So isolate y. I will subtract 3x from both sides. I get 2y equals negative 3x minus 2. And then on that equation, I'm going to divide everything by 2. And I wind up with y equals negative 3 halves x minus 1. This is the equation that I'm going to graph. It's the same line as the one we were presented with at the beginning, but now it's in a graphable form. So again, I need to label my axes and give myself a scale. So I would like to go, I want to let this be 1 and let this be 2. 1 and 2. Just makes a little bit better use of my graph, given the size of the numbers that I have. I'm going to start at my vertical intercept. Vertical intercept is 0, negative 1. So that's going to be, if this is 2, this right here is 0, negative 1. And then my slope tells me I'm going to go down 3 and to the right 2. So from here I'm going to go down 1, 2, 3, and to the right 1, 2. Remember, I'm skipping a line each time because of how I've scaled my axes. Or I could go up 3 and to the left 2. 1, 2, 3, 1, 2. And from here I can graph that line. And that's about it. So, the next thing I'd like to do is you find something called point-slope form. So, first I want to show you where it comes from, and then we will use it, and then we will take a break. So, I want to start by talking about the equation for slope. You guys might remember that the equation for slope is m equals y2 minus y1 over x2 minus x1. So I want to see what happens to this if I clear my fractions, which you may remember means multiply by the common denominator. So for us, the common denominator is going to be this x2 minus x1. So I'm going to rewrite this down here. M equals y2 minus y1 over x2 minus x1. And I want to multiply both sides by that x2 minus x1. So over on the right-hand side, those two cancel out. So right now, I am left with x2 minus x1 times m equals y2 minus y1. This is actually in pretty much exactly opposite the order we want to write this. But before we rewrite it, I want to talk about this slope for a moment. y2 and y1 are two y coordinates, so I was given 2 points. x1, y1, and x2, y2. Just 2 points on the line. What this form of the line is going to do is say, I don't care what my other point is. I know that it's in x y pair. So we're going to rewrite this point as just x, y. So I'm going to rewrite my equation down here. Actually, let me not do this in red. Let me do it in purple so it's a new color. So I'm going to rewrite this ordered pair as just x, y. So I'll do that down here. I am left with then, if I do that, x2 minus x1 times my slope. I don't want the 2 anymore. I just said that. X minus x1 times my slope equals y minus y1. So now I'm just going to switch up the order. And I'm left with y minus y1, I rewrote this, equals, I'm going to put my slope first, and then x minus x1. So what this allows us to do is, given the slope and a single point on the line, I can get the equation of my line. This allows us to get the equation of the line from any point and the slope. So your book has this equation. This is what your book says exactly. I copied and pasted this from the book, and this isn't going to work. I will resize this when I publish the notes so that they're all on the same page. So this is what your book says about that. I want us to use that equation to find the equation of the line with this slope and this vertical intercept. This other point on the line. So I'm going to rewrite point slope form. Y minus y1 equals m times x minus x1. For us, 2, negative 4 is going to correspond to x1, y1. And m is negative 2. So I can put this all together. Y minus negative 4 equals negative 2 times x minus 2. I need to first distribute this negative 2 through. So I wind up with, I'm going to combine this a little bit, y plus 4 equals negative 2x plus 4. Negative 2 times negative 2 is 4. And then I want my line in slope-intercept form, y equals mx plus b, so I just need to isolate y. If I subtract 4 from both sides, they cancel. I'm left with y equals negative 2x. Now, some of you remember a different way of doing this. You may have done this if you took Math 65 with us here at LBCC. Another way we could do this is we could say in y equals mx plus b, negative 4 equals 2 times negative 2 plus b. If I do it this way, I find negative 4 equals negative 4 plus b, and the only way this can be true is if b is 0. B ends up being 0 in both cases. So once I've found that b is 0, I need to rewrite this equation, just my regular y equals my slope times a regular x. And I get the same place. We like point slope form because you don't have to remember to do anything. You plug things into a form and you get the slope-intercept form out as the final result. When you do this the Math 65 way, you have to plug the equation back together at the end. It's not as tidy. On a test, you are welcome to do either method that feels comfortable to you. The next thing we want to do is find the equation of a line through two given points. And I'm going to do this using point-slope form. But I don't have my slope. So the first thing I need to do is find my slope. So that's the m equals y2 minus y1 over x2 minus x1. For us, it doesn't matter which one is my y2 and which one is my y1. So I'm going to say 4 minus 0 over negative 2 minus 3. So if I finish this out, I'm going to get a negative 4 fifths as my slope. M equals negative 4 fifths. So the equation of the line would be y minus, pick one of your 2 points. I like to use a 0 whenever possible. So y minus 0 is going to equal negative 4 fifths times x minus 3. So y will equal negative 4 fifths x. Negative 4 times negative 3 is a positive 12, and then that'll be over 5, because the denominator of that 3 is a 1. I am not going to spend the time going over how to multiply the fractions. When all is said and done, that was not good. When all is said and done, this is the equation of my line. Now, we may have made a mistake. We may have made a mistake in our slope equation. We may have made a mistake in our distribution. So we're going to check this. We're going to plug in a point. And it should be the other point, not the one we used to find the point-slope form. We're going to use the other form, the other point. So I'm going to let y equal 4. 4 should equal negative 4 fifths times negative 2 plus 12 over 5. So 4 should equal negative 4 times negative 2 is positive 8 fifths plus 12 fifths. 8 fifths plus 12 fifths is 20 fifths, which equals 4. That means we did it correctly, and that gives us a great big smiley face. That's the first several objectives of this section. I'm going to take a break, and I will start up another video to cover the last few objectives. Talk to you soon.